Alright guys, this is one of my favorite topics, the anatomy of node packages. Have you ever worked with packages? Of course you are. Of course you did. Package, node packages, NPM, Yarn, all these fancy package managers. What are these? We're gonna break it down. I want you to just take time to relax and then give this part of information the ability to, don't fear to explore what's behind all of this stuff. And let's just jump into it. You see, you can work with individual files in Node normally. You can have a file that reference another file, that reference another file. But then tracking this dependency becomes a challenge. That's why Node, as part of their architecture, invented these packages, right? It's an abstraction on top of, it's nothing but a metadata file that tells you that this file requires this file, this file, this file requires this file, requires this file. Otherwise, you don't know, right? You have to store this information. You can track it yourself if you want. You don't need to use packages at all, right? You can just say, hey, I'm using this file, which reference this file, which reference C, which reference D, and you can just build it yourself, understand it. But packages help. It's a tool. Everything is a tool, and it's up to you if you want to use it. So meet our first friend, package.json. It's a manifest. It's a metadata that describes the current package, i.e., hey, I'm about to create a package, and you initialize a package, and this is the start of the file, and here's my stuff, and here's what I need, and you can define all these dependencies. It defines the current package and everything that I need, because remember, that's what the package is. Package is what is the current file and what does it require. What other packages does it require? So you, by definition, you have a name for the package, something you didn't have before, right? Because files have file names, but you don't have a package name. You didn't have like a node name or what I'm looking for. You don't have a package. Package name is a new thing. It's a metadata. Like your project name is different than the file name, if it makes sense. So this is an introduction of a new abstraction that's called the package name. And it is in the package.json, right? The other thing we need to understand is the semantic versioning, right? And I keep forget to read this, but essentially it's always this or this, right? If this is a tilde or this caret. If you have a caret, it means, hey, you can use this package up until version 1, but never exceed version 1. That's what it means. So these two guys, the minor and the major, the minor and the patch, can go anything as it. So this is called the major. This is called the minor. This is called the patch, right? And in this particular case, if I say fetch caret 110, it means I can use this from version 110 up until version 200, right before 200, i.e. anything like 199.99 forever, essentially, right? So you can use that. That's what semantic versioning is. You can define the package to have a dependency, and you can lock into a version like 110, or you can say, I want to get the patches, the fixes for this. So I want the major to stay the same just to avoid breaking changes. But hey, you can improve the minor version and the patch, right? That's fine. And similarly, if you use tilde, then you are a little bit more restricted. Tilde says, hey, these two guys should be fixed. Only the patch can increase. So if I say tilde 760, it means, hey, from 760 up until 77. Never exceed 770. So the maximum minor you can get is 6. So you can go crazy with the patches, like 761, 762, 769, 7612. You can go right with that. And the final one is basically using hard-coded version. Say, hey, 763, and I don't want to do anything. Of course, the package.json only has the direct dependencies, you guys. The direct dependencies. It doesn't care about dependencies of the dependencies. It doesn't know them. You say, hey, I am this package.json. I'm about to reference fetch. I'm about to reference fs. I'm about to reference this. You don't know what fetch references, and you don't care at that moment of time. At least in the package.json, this manifest. You don't know. You just, that's where you're stuck at. What is the other job? That's a job of another file. Okay. So here's an example of a package.json. So we're introducing a name, which didn't exist before. Now you can name your package, right? Because like if you write a file, Node.js, you just give it the file name. But now we're introducing more. We're using the main, which is what is the starting point of the file, this package, which file should we start with to run it? And then what's the name? What's the version? You have a version. That's a new thing too, right? So with packages, we introduced a version, we introduced a name, we introduced a starting point, we introduced tests. If you want to run scripts, like, hey, I want to run a test, I want to run an install, I want to run this and that, the author, the license, description, all metadata, which I don't care about. This is what matters. The direct dependencies. It's an array of key value where the name is the package name, which is just another package that has a package.json that happened to have a name that happened to be called fetch, right? It's no magic. It's just recursive reference to another package.json. So there is another package.json that reference load LOD-ash. That's another package, I suppose, right? And here's the thing. This is the version. This tells me that, hey, I'm fine referencing version 1.10 and above as long as you don't bump up the major. Stay at release 1. 1.20 is okay. 1.30 is okay. 1.35 is okay. 1.99 is okay. But 2? Nope. Don't use that. Same thing here. 4.17.21 is okay. That's the minimum. You cannot go below that. Don't use 4.17.21. 20, sorry. You have to go this and higher. 4.17.25 is okay. 4.18.21 is okay. And so on, right? Meet package lock.json. This is very critical file. And it's a terrible name. The first time I saw this, maybe 7 years ago, when I saw the log file, I thought it's somehow like because like I come from databases, right? And I thought it's like, hey, someone is locking this file because someone is reading it. And I thought it's like, hey, it's just, you can just delete it, because log files, if they exist, that means you crashed and you left it, right? So package lock is a bad name. If I would rename it, I would say package fixed, maybe something like that. I will name it something else, but that's what it is. Package.json describes the latest possible based on semantic versioning. So if I give you my package with just the package.json and I say, hey, install this, you will look up the package.json. You will find that these are the dependencies. And what you're going to install is going to install the latest possible allowed by the semantic versioning, right? Based on this guy. So at a moment of time, if I install this, I might get 1.10.47.22, right? But a month later, if you install it, again, assuming there's no lock or anything, package.json, if you install it, you might get 120 and you might get 418.0, because at the moment of when you installed, you looked up the fetch, you looked up what we're gonna call up a package manager online, because that's where you're looking up fetch, right? Modules need to be looked up somewhere, right? We looked it up, and it says, hey, you can define where to look up as well, right? And we looked it up and says, hey, this is the latest. We installed it. So I and you are running different versions. So I might see different result than you. And that's a problem, right? Sometimes you need consistency. Sometimes you say, hey, yeah, I need the good latest stuff, but for consistency in my project, I want you guys to agree on a specific version that I run my test on. At the moment of installation, here is a stamp of all the stuff that we did. And that's what it is. It's a snapshot of the installation. So package.lock.json includes every possible dependency of dependency, and no semantic versioning. They include the exact versions. And it says, hey, at this point of time, someone has installed. If you see package.lock, that means someone has actually installed something, right? And we're going to come to what has been installed in a minute. But yeah, we need package version dependencies, and that's where package.lock.json here. Terrible name, but it is what it is. Fixed, let's call it. And it's used for consistencies because it has all the packages that has been installed at that moment of time. Here's an example. Here I have a test package, and I referenced two things, remember? Load S and fetch. But fetch, this is the lock.json, all the packages are here. Every single package. Fetch, it goes into a place called node modules. We're going to talk about it in a minute. Downloaded stuff. And then it says, hey, it was resolved from this particular URL. This was the integrity hash for this. It was this license. And it referenced, this was the version that was installed. See, there's no semantic versioning, 110. And guess what? The dependencies that was used for this guy is this and this. And it's this version and it's this exact version. If you look it up, you will see basic fit, whatever this is also in the package.lock.json. So everything you look up here, you'll find it. In coding, you'll find this, and you'll find if there is like a dependency for this. So that's what package.lock.json. So by definition, if you have package.json and package.lock.json, and you push these to the GitHub repo, and someone else clone your repo and say, hey, npm install or yarn install, that package manager will look up the package.json and will look up package.lock.json and say, oh, this guy already installed all of this stuff. So I am going to exactly match whatever is in the package.json. I don't care if there are newer versions that satisfies the semantic versioning. I don't care. I'm going to follow exactly the package.lock.json. And I'm going to follow where I'm going to look it. I'm going to use these URLs. And I'm going to load exactly that. And I'm going to verify all of this. So this ensures that you're, as they call it, continuous integration, that you're consistent. If you are in the dev environment, you push something and you're in production, you don't all of a sudden install in the production and you get a newer version. You don't want that. You want to be consistent, right? So that at least predictable. Because if you run into a bug, you want at least to debug you want to remove unknown factors like, oh, all of a sudden you installed a new version and that version behaves differently, and even the node version can completely screw everything up, right? Let's talk about this puppy, node modules. After you install something, it's good to cache it, right? And this is where the cache go. Every possible package and all their dependencies goes into this folder by default, and this folder is called node module. And if you go, what are you gonna see? You're gonna see package.json, which tells you the script, of course, of these guys. You're gonna see the package.json, which describes this package, and of course your package log.json. And that's it. This is where node modules is. It's the snapshot at that moment, downloaded all the scripts. Without node modules, you cannot run anything. You're gonna get failures, because as you run your code, it's gonna start looking for fetch, and it will say, hey, cannot find fetch. Where can I find fetch? It will tell you this is the location of fetch. Node modules path / fetch. So if you don't have it, you can just install it. And which this means that this could be reproducible, because this first of all, this means that this is a massive folder, and it's really a bad idea to push it to Git, and it's completely useless. Why? Because this is this can be generated identically in every single machine using the package lock.json. If you have the package lock.json, you get identical node module. So that's why people say, hey, don't push node modules, because you don't really need to, because you can always generate it. But you have to push. Well, you don't have to. Package.lock.json, right? This is what generates this. If you don't have package lock.json, do you still get node modules? Absolutely, right? You will get two things. First, if you only get the package.json, you're gonna get whatever is the latest based on your semantic versioning, latest and greatest, right? It's gonna respect that, and it's gonna generate a package lock.json, giving you the entire meta manifest. And then, of course, it's going to download all this data and put them locally. Package managers. All of this stuff that we talked about, you can do it yourself without a package manager. You can write a script that parses the package.json and then, of course, look up modules wherever you want, and then generate the package.json lock, and then download it into a node modules or any folder that you like. But that's a hassle, right? So package managers take care of all of that. They host that stuff for you. Host manage packages, right? They download and install. They update the package.json and package log.json, but it's not magic. That's why people prefer to use like Yarn versus npm versus whatever another. Look, there is npx now. I cannot keep track, to be honest. There's so much stuff. But essentially, it's all doing that, and people brag about, hey, this is being faster than this, or like Bun has his own package manager, right? So like everyone's like, oh, this is faster than this, because it's just code at the end of the day, right? This code needs to parse the package.json, quickly look up URLs, quickly download them, and if you're smart enough, you can concurrently download as much stuff as possible, throw them locally, swizzle, and change everything in package.json to point to the local path. And just like that, everything works. So examples are npm. Of course, I'm going to use npm. It's the OG, right? And download the node modules. And yeah, we're going to do init. npm init creates a brand new package.json if you don't have any, okay? Because again, npm stands for node package manager, right? And package.json is a thing that describes a package which you don't have by default. You create it from thin air. Here's an example. Following the whole stack, you have the main package.json, And this is the log file. By the way, this is the log file version, because as you move through package lock.json, you move through versions of this file itself, right? So you need to know which version so you know how to read it, essentially. So main package.json, reference load sh, reference fetch. Fetch references these guys. This reference this reference this. You can see that there is like it's a graph, nothing but a graph. Modules or packages are nothing but a graph. And these special guys are leaf packages. Leaf packages are packages that they don't reference anything else, and you need those, right? You don't need you cannot be referencing. I suppose you can have cyclical packages that references another packages, but then at the end you need to stop, right? At some point. Consideration, we talked about that. You don't need to push node modules to get, right? It's just pointless to do though, right? It's just massive, right? And you can always generate it if you want to. Comes a point like, hey, what if I don't have internet and I want to play games? Yeah, in that particular case, you can push it to your local repository that is not connected to the internet, and you can definitely push node modules to your repo. So we're not stopping you from doing that. But essentially, if you're into that, then you're going to host your own package manager repository locally in your enterprise, and you point everything to that, right? As opposed to from the internet. So that's all stuff you can do as well. So there's so much there with packages. Yeah, we talked about that. You need to push package.json and package lock.json if you want consistency. If you don't care about consistency, don't push this. You don't have to. This way, all clients have repeatability, right? Otherwise, you don't get that. Ideally, you also need to push, and I don't think if there is something like that, maybe Jenkins supports it, but you want to also push an image, Docker image, that image file, Docker image, what is it called? Docker file that gives you, hey, this is the exact Docker file node version to use. So this way you're even consistent across the board, because just having package.json and package log is not enough, right? Because someone can have different node versions and you can get different results. So you need to also match the runtime. Summary: package makes dependencies easier. It's managed by a package manager. 3 more main folders or files, right? Package.json, package log, and then node modules. And let's go through our exercise. We're going to create a package.json. We want to reference node fetch, which is a different library than the built-in fetch, right? Just for testing purposes. We're going to view the latest npm. That's what you do. You can do npm view node fetch to find out the latest one. And the latest will be, I think, 332. They didn't update it for years. But I'm going to reference on purpose. I'm going to reference 331. Just because I want to be different and I want to prove that how package JSON works, essentially. Okay, I have a command here less so that you can start this exercise. But here I have a node fetch, and I'm just doing literally nothing. This file does nothing. It's just an example of how to do that. So I'm gonna cd change directory into the 11 package. Wait a minute, cd 11. Oh, it is package.json. Package.json is the folder, and I'm gonna do npm init. I'm not gonna do -y so I can show you what all the stuff here. It's gonna ask me a question. What is your package name? My package name is a test package. Oh, you cannot have spaces. I did not know that. How about this package? Do you like that? Okay. My version is 7001. Description: this is a test package. Can I do spaces? Thank you. All right. So I cannot do spaces in my package name, but I can do it in the description. Got it. Git repository, I don't really have. Author, Hussein Nasser. License, MIT. Is this okay? Yes, sir. And so look at that. It generated a file node fetch 331. Where is this? Where did this get? Where did this get? Where did it get this 331 from? I honestly don't know. Oh, maybe I had the package.log.json. Wait a minute. Whoa. Something is not right here. Something is not right. I think it has some cache going on here. Is there some cache? Because definitely I did not do that. All right. Something's not right. I'm going to delete this. Because we're not supposed to get a log file here. Maybe I had it before. I don't know. So I'm going to do npm view node fetch. And if I do npm view node fetch, you can see the latest is 332, right? But if I run my program node 110 index, you can see that I'm going to get an error. And the error says, cannot find module node fetch. Because what it happens is, it tried to load this and it assumes it's a module, right? Because there is no extension. And it looked up the package.json and it did say, hey, yes, it is indeed you're trying to reference, not really. No, let's do it again. Let's do it again, guys. I'm going to delete this package.json, right? And I'm going to do it one more time. npm init -y this time. Okay, this time I'm getting the correct one. It's just odd. I don't know. I think it was a cache somehow. npm cached my stuff, so it remembered what I did before. Anyway, this is what we were supposed to get. We're supposed to get no dependencies, no packages, nothing. So node 110, we're going to get an error saying cannot find modules node fetch. Understandably so, because hey, there is nothing called node fetch here. And I look up at a package, there is nothing here called node fetch. So what I'm going to do here is I'm going to do npm view node fetch. And I'm getting a lot of tags here, but this is the latest 332. I don't want to install the latest 332. I want to install 331. So I'm going to go do install node fetch, and this is how you install specific version 331. So this, if you do npm install, that updates your package.json and downloads that specific package. Well, not in that order. First, it downloads that package, put it in the node module, and then it updates your package.json and also creates a package lock.json for that particular version. Okay, so I'm going to go ahead and do enter, and that installed 6 packages and audited 7 packages and bunch of other stuff. And you can go in the package.json, you can see that, hey, the dependency in this particular case is 331 and above. That's what we did here. So you can go up to 331. That means 332 is okay, if you think about it, right? Because that's what this caret means. If I go to package log.json, you can see that what was installed is, this is my package, and that's the name of my package, and it's referencing node fetch. Let's go close all of this stuff so I can show you. Node fetch. Let's go find node fetch. Man, node fetch is doing a lot of stuff, huh? Where is node fetch? Node fetch. We installed version 331. And this is the library. This is the URL. This requires the particular dependency. Now, the dependency itself, of course, has semantic versioning. But if I pick fetch blob, you can know exactly what version was installed, right? 314 was preferred, but what was installed is 320. So we went all the way to we updated the minor. So this this is exactly the version was installed. And you can follow this and you can see, like, any version is always like hard coded. I say hard coded, but you know what I mean, right? This is the actual exact version. Boom, 333. And that's it. That's the package.log.json. And we also got node modules. Look at that. Node modules itself has also a package log.json. And this describes my package log.json and other stuff too. All the packages, right? So we have dot package log.json. Looks like it's slightly different. But node fetch, you can go here. You can see which version was installed. A Livewell module that brings fetch API to Node.js. The details. And it tells you, hey, here's my dependencies. All the dependencies. This is the div dependencies. Let's not go there. This is the stuff that you installed during the div environment, right? But this is the actual dependencies in production. 3. Boom, boom, boom. And we have, if you go follow it, you can find pretty much the actual raw files for execution. Now, if I do node, it actually runs successfully because it located package.json and found the actual files and it downloaded all of this stuff. So now, if I go and delete node modules and I run it again, it fails. Naturally, right? Because it could no longer find the package.json, the node fetch files, because it's trying to look it up. It says, hey, I looked at node modules and it's not there. So what do you want me to do? So you can just do npm install this time. Not npm install node fetch, but npm install without anything means, hey, look at my package.json, look at my package log.json and follow that pattern. And if I install, I better get 331. If I don't get 331, then we're not consistent. So we are consistent, we got 331, and that's basically how Node package managers work in a nutshell. Pretty cool stuff, huh? And hey, by the way, you can say the engines and you can say, hey, I'm supported in these kind of Node releases. All right, guys, that's all for the packages. Let's move to the next lecture and the final one in the architecture section.